Before we get started, are there any questions over the homework? Yes? Number 17. Describe the end behavior of the graph of the function. So we have this function here. Now, when we describe end behavior, we do need the degree and leading coefficient. Now, the degree for this is 4. The leading coefficient is -5. So our degree is even, and the leading coefficient is negative. So those are the 2 points that we have. Now, for this here, we would just go back to the chart. And have this pull the chart up. Right here. Degree is even, leading coefficient is negative. So these 2 parts here are the answer. F of x approaches negative infinity as x approaches infinity, and f of x approaches negative infinity as x approaches infinity. So f of x arrow negative infinity as x arrow positive infinity, and f of x arrow negative infinity as x arrow negative infinity. That's it. Questions on this here? Because that is similar to what the chart says, but instead of having it written in kind of a more stacked form, because the chart has the f of x arrow negative infinity on top and then the as x arrow positive infinity on bottom, we can just write it as a single line. Questions on 17, 18, 19? Because I think it's those 3. So it's just looking at the chart, picking which one goes with it. Because the f of x, the arrows in both cases in this are understood, or we denote them as approaching negative infinity or positive infinity. Any other questions on the homework? What we're looking at today is addition, subtraction, and multiplication. Addition and subtraction is, well, addition is what we're going to look at first. And there's 2 ways we can add and subtract polynomial expressions. One of them is vertically. And when we add and subtract vertically, vertical, up and down, we're going to be adding and subtracting up and down. So it's wanting us to add 3x cubed plus 2x squared minus x minus 7, and our x cubed minus 10x squared plus 8. So since it told us this one here was first, we'll put it first. So we'll put 3x cubed first. We'll just write it back out. If there are any missing, any terms missing, so here the biggest term is x cubed, so we'll need an x squared x constant. If one of them's missing, we'll leave a spot. But here, no terms are missing. Then we'll put the other one underneath it. So we'll line up the like terms. So x cubed is first. It goes under the other x cubed. Next one's 10x squared minus 10x squared. We put it under the x squared term. We're lining our terms up. Our x term, do we have one? No. So I'm not going to put anything under the negative x. And then I'm going to put our plus 8 under our minus 7. So we just line the terms up. Questions on this here? If the top one had been missing a term, we can just leave a little bit of a space so that we're not misaligning them. And this helps us to be able to just combine like terms. And again, we're going to add the two together. So we can just go down the row. 3x cubed plus x cubed is 4x cubed. 2x squared plus negative 10x squared would be negative 8x squared. Negative x plus nothing is just negative x. And negative 7 plus 8 is 1. So plus 1. So our final answer when we add these two together is 4x cubed minus 8x squared minus x plus 1. That's it. Questions on this here? This is a little different. We're not used to adding polynomial expressions or adding expressions like these vertically. Most likely the last time you added two things vertically is when we looked at two numbers, 47 and 32. Put them over the top of each other and just combined, added from right to left. We do ones, tens, hundreds, going that way. Here, we could go either direction because, well, there's no way that I can add two numbers to constant terms, so 7 and 8, and somehow magically get a term with x. That's different from numbers. If I added two-digit numbers, I can get a three-digit number. Here, we can't cross over. Questions? Yes. Combine like terms, yeah. Yeah. Because we can also add horizontally. This is what we're used to. Because when we add two things horizontally, we're saying 9y cubed plus 3y squared minus 2y plus 1 is being added to negative 5y squared plus y minus 4. This is what we're used to doing. Since there's not a sign in front of the first set of parentheses, we can just drop them. One more time. Here we don't have to because we're not lining them up. Because if we did it vertically, yes. I would offset it so that the y squareds line up, the y's line up, the constant term, so they're all lined up. Here, because it's just horizontally, we have it listed out, I don't have to leave a space for the y cubed because we're not having to line them up vertically. Now here, when we distribute, we can think of this in two ways. One, we can distribute that positive 1, which doesn't change a thing, so we can just drop the parentheses. Because we still have plus negative 5y squared plus y minus 4. Most of the time we don't think of it as plus negative 5y squared, we just think of it as minus 5y squared. Either's right. We just normally write it this way here. Questions on this so far? Now there's two different ways we can go from here, and it's not that one's correct and one's incorrect, one's just shorter. Because the longer of the two ways is that, well, I can rearrange my terms. Because we have 9y cubed. The other term doesn't have y cubes because it's the only like term. We have our positive 3y squared, and its like term is negative 5y squared. That's the only y squareds. We have our negative 2y and our positive y. And then we have our plus 1 and our minus 4. And I just rearranged them so that the like terms are next to each other. Now, if you noticed this that I wrote something underneath each term as I kind of rearranged them, put them together. I do that. That is, bless you, that is not a set style. That is not a set method. That is something I do personally to just make sure that I have every term accounted for. And I use a different symbol for each set of terms so that I know that I'm putting the correct terms together, that I have them accounted for. Does that make sense? It's just a way for me to keep track of terms. Now for this here, since we only have 2, 4, 6, 7 terms, it's not too bad. I did this a lot of times, especially when we had doing calculations or combining like terms with 14, 20, 26 terms. It can get a little confusing.
McFerrin, come to the office. Sean McFerrin, come to the office.
And the last thing to do is just combine like terms. Well, 9y cubed is already simplified as it gets. 3y squared minus 5y squared is negative 2y squared. Negative 2y plus y is negative y. And 1 minus 4 is negative 3. That's it. Realistically, this step here, we didn't necessarily have to put the like terms next to each other. We could have gone on and just combined them. But that's it. Questions on this here? We're ready for the next one. Addition, subtraction, addition. Now, whenever we add or subtract, it really doesn't matter if we do it horizontal or vertically. You just need to pick one and do it that way. Do we want to add these horizontal or vertically? Vertically. So I'd pick the first one first. 2x cubed plus x squared minus 3x plus 4. Over. The second one, we have our x cubed term, so just x cubed, plus 7x squared minus 2. Just like the first one we did vertically, they left out the x term, so we kind of leave a space there so we don't combine unlike terms. And at this point here, we're going to add. I do put the addition sign between each set of like terms, just as a reminder to myself that I'm adding. Now 2x cubed plus x cubed is 3x cubed. X squared plus 7x squared is plus 8x squared. Negative 3x, just negative 3x because we don't have anything here. 4 plus negative 2 is plus 2. Questions on this here? I think we feel pretty comfortable with addition. All right. Yeah. It's a familiar concept in a new form. Subtraction, vertically. Realistically, with addition, even if you got it flipped, you would get the same answer because adding two things in any order gets you to the same spot. When we subtract two terms, whichever one they list first, we're going to subtract 2x cubed plus 6x squared minus x plus 1 from 8x cubed minus 3x squared minus 2x plus 9 in a vertical form. Whichever one comes first is the one that goes on top when we do vertically. So our 2x cubed plus 6x squared minus x plus 1 would come first, leaving our 8x cubed minus 3x squared minus 2x plus 9 second. And this time, instead of adding, we are subtracting. And again, just like with the addition sign, I put the subtraction sign between every like term as a reminder to myself that I am subtracting. Yes, and then we go and subtract each term. So for the first one, we have negative, or not negative, 2x cubed minus 8x cubed is indeed negative 6x cubed, because we're doing 2 minus 8 gives us negative 6. 6x squared minus negative 3x squared minus a negative makes a positive. 6x squared plus 3x squared is plus 9x squared. And that's one thing I do like about putting the minuses between each term. So for that second one, because we had a minus negative, I can go in and change it to plus, and we get our 9x squared. The next one, negative x minus negative 2x. Well, the negative gives us plus. So negative x plus 2x is plus x. And our 1 minus 9 is negative 8. And that's it. We cannot, unfortunately, because the graphing calculator, well, the 84 plus CE, and the TI-30XS require x to have a value. They actually have to have a value for x. And since our answer is not not just a number, a simplified number like 84, since we have negative 6x cubed plus 9x squared plus x minus 8, neither one of these will do that. I'd have to look into the inspires because they might. I know the 89s are able to add, subtract, multiply, divide these polynomial expressions. They're able to solve. They're able to do tons of stuff. But they are banned on pretty much every single standardized test because they do it for you. Let's look at this one here. So this time we're doing it horizontally. So we have 3z squared plus z minus 4 is being subtracted with 2z squared plus 3z. Questions on how we set this up? Now the first set of parentheses, we don't have a symbol in front of it. It's understood to be positive, so we still have 3z squared plus z minus 4. But we're subtracting from it our second set. So that subtraction sign has to be applied to both terms. So now we have negative 2z squared minus 3z. And that's something we do need to be careful about, that we're not applying the negative to just the first term in that second set of parentheses, but to every term. And at this point here, we can put the terms next to each other. So we'd have our 3z squared and negative 2z squared. Our positive z and negative 3z. And we have our minus 4. If we combine like terms, 3z squared minus 2z squared is z squared. Z minus 3z is negative 2z. And we still have our negative 4. Questions on addition, subtraction, or subtraction so far?
John McFerrin, come to the office. John McFerrin, come to the office.
Do we want to see subtraction one more time, vertically or horizontally? Horizontal. Which one? Horizontal. So if we look at this one horizontally, we list them out. So 3x cubed plus 5x squared minus x plus 8 is being subtracted from 5x cubed minus 4x squared minus 3x plus 1. When we add or subtract vertically or horizontally, straight line, we do put parentheses around the first thing we're adding or subtracting, our symbol that we're using, and then our second set. Now at this point we can drop the parentheses for the first one and nothing changes. So we still have 3x cubed plus 5x squared minus x plus 8. However, we have to apply that subtraction sign to every term in the second set of parentheses. So our positive 5x cubed is now negative 5x cubed. Our negative 4x squared is now positive. We're just flipping the signs. Our negative 3x is now positive 3x, and our positive 1 is now negative 1. Because we're saying we're subtracting everything in that second set of parentheses from the first. So we're subtracting our 5x cubed, which makes it negative. We're subtracting our negative 4x squared. Well, a negative and negative make a positive. We're subtracting our negative 3x, which makes it positive, and we're subtracting 1, which makes it look negative. At this point here, if we want to put the like terms next to each other, we can. Because our 3x cubed and our negative 5x cubed. Our positive 5x squared and our positive 4x squared. Our negative x and positive 3x. Positive 8 and negative 1. And at this point here, we can simplify like terms. 3x cubed minus 5x cubed, negative 2x cubed. 5x squared plus 4x squared is plus 9x squared. Negative x plus 3x plus 2x. And 8 minus 1 is 7. And that's it. Questions on this here? And for the most part, adding or subtracting vertically or horizontally, there's not a big difference between them. It's just picking which one you like better and sticking with it. Would you feel good with addition and subtraction? In that case, we're going to move on to multiplication. Now we can multiply things vertically and we can multiply things horizontally. I'm going to show you this vertically. I would not write this down. It's not the method I would advise using because it is a little weird. It works just fine, but it's a little weird to conceptually think through. Because if we multiply this vertically, the first thing we're going to do is multiply by 3. So we'll do negative 3 times our 4, which is negative 12. Then we'll do negative 3 times 2x, which is negative 6x. And negative 3 times negative x squared is 3x squared. Then we move over to the x. Well, kind of like with vertical multiplication with numbers, we would move over one spot because we can add a 0. And now we're at the x. X times our 4 is 4x. X times our 2x is 2x squared. And since it's positive, we're really adding a plus. And x times negative x is negative x cubed. Or x times our x squared would give us 3. Because x and x squared. Yep. And at this point we would add straight down. So our negative x cubed, because there's no other x cubed terms, our 3x squared plus 2x squared is plus 5x squared. Negative 6x plus 4x is negative 2x, and negative 12 plus 0 is negative 12. And we get this here. I think it's a little easier if we multiply this horizontally. Because if we do horizontal, this is something we're used to, our distributive property. First thing we'll do is multiply through by our negative x squared. Negative x squared times x is our negative x cubed. Negative x squared times negative 3, negative and negative make a positive 3x squared. Then we do it again with 2x. 2x times x is plus 2x squared. 2x times negative 3, negative 6x. Then we move to the last one, 4. 4 times x is plus 4x, and 4 times negative 3 is negative 12. Incidentally, just because how this one was arranged, our like terms ended up being next to each other. Negative x cubed does not have any like terms, so it's just negative x cubed. 3x plus 2x is plus 3x squared plus 2x squared is 5x squared. Negative 6x plus 4x is negative 2x. And then we have our minus 12. Same exact process as what we did vertically, but we're a little more comfortable with horizontal. Questions on this here? This time we want to multiply y plus 5 and 3y squared minus 2y plus 2. So we're going to multiply this horizontally. So the first thing we're going to do is distribute the y. Multiply through. Our y times 3y squared is 3y cubed. Y times negative 2y is negative 2y squared. Then y times 2 is plus 2y. We can do the same thing with 5. We're going to distribute it through. 5 times 3y squared is plus 15y squared. 5 times negative 2y is negative 10y. And 5 times 2 is plus 10. Questions on how we got to this part here? Now at this point we can combine like terms. Now our first term is 3y cubed, because there's no other like terms with it, yes? Now we can do the same thing as we've done before. I put the y squareds next to each other, y's next to each other, constant terms next to each other. But let's look at this from left to right. Our first y squared term is negative 2. Our next one is 15. Negative 2 plus 15 is positive 13, yes? I don't necessarily, there is no written rule that says we have to put them next to each other before we can combine. We can combine at this step, which also helps with doing the symbols, because as I add or subtract them, put a symbol just to make sure, kind of checking it off that I have calculated it in. And if we want to use a calculator for this step, we can. We can't put the variable, but I could put the numbers negative 2 plus 15, do those, put them all in, hit enter. Negative 2 plus 15 is 13. We know it's connected to y squared, so it's positive 13y squared. Then we can move on to the y terms. 2y minus 10y is negative 8y. And lastly, we have positive 10. And that's it. Questions on this here? good with multiplication. Do we need to see another example of multiplication? We feel comfortable with these here? Yes? Good? Okay. So we're going to skip a little bit ahead to these here. Well, here we have 3, yes? The nice thing with multiplication is we can multiply any 3 things in any order. I just have to pick which ones we want to multiply first. Now we can't just multiply the x minus 1 by the x plus 4 and x plus 5 at once, because we only have one of them. Yes, because I can multiply these two and then their product with x plus 5. Or I can multiply these two together first and multiply their result with x minus 1. Or if I wanted to just be fancy for some reason, multiply the x minus 1 and x plus 5 first and then multiply their result with the x plus 4. We could do that also. I'm least likely to do that because it's jumping the one in the middle and we're having to keep it all straight. Normally, I either go first 2 or last 2, whichever one has a simpler product. Here, we can do the first 2. Parentheses, x times x is x squared. X times 4 is plus 4x. Negative 1 times x is negative x. Negative 1 times 4 is negative 4. Now we left the parentheses this time, unlike the last time, because we still have something we have to multiply once we're done. Now it's not incorrect at this point to go on and multiply these two together at this point, but I would advise against it. The first set of parentheses, are there like terms? The 4x and negative x. It's going to be better to go on and combine those before we start multiplying again. And it would save us a step. It also gives us, in this case, 2 additional terms from the 4x and negative x. Well, yeah. Because here, 2, 4, 6, it would give us 8 terms at this point. Let's see how many we get here. X squared times x is x cubed. X squared times 5 is plus 5x squared. 3x times x is positive 3x squared. 3x times 5 is plus 15x. Negative 4 times x is negative 4x. And negative 4 times 5 is negative 20. So here we got 6 instead of 8. So it saved us 2 additional terms. And those 2 additional terms would have both been either, one of them would have been an x squared term, the other would have been an x term, but it would have still gotten us to the same result. X cubed. Well, 5x squared plus 3x squared is plus 8x squared. 15x minus 4x is plus 5x minus 20. So having 3 of them is really not any different than 2. It's just we have to do the multiplication step twice instead of just once. Questions on this here? Any questions on anything we've done so far? I think we feel good with 3, yes? Core concept, special product patterns. Well, at this point with factoring, one of the ones that we like to factor most likely, that is an assumption, but is our a squared minus b squared, our difference of perfect squares. Because if we have x squared minus 9, I know that it factors to x plus 3 and x minus 3, yes? The reverse is also true. If I have x squared, or x minus 3 times x plus 3, difference of perfect squares, so it should multiply back to be x squared minus 9. Because if I know that this is a difference of perfect squares, that it should go to x plus 3, x minus 3, yes? The reverse is also true. Different signs, but same first number, x and x, 3 and 3. Square the first, square the second, and we get back to what we started with. Yes? So that's kind of one of the special product patterns. Square the binomial, square cube of binomials. We haven't done much with sum and difference of perfect cubes yet. We will cover that this chapter. Square binomials, this is more just memorizing a set pattern of how this works. If I have a squared plus b squared, it's going to multiply out, or a plus b squared, quantity a plus b squared, will multiply to be a squared plus 2ab plus b squared. It's just knowing that pattern, plugging in a and b. And for most, having this memorized and actually multiplying it out is not too much faster for y'all at this point. You'll be able to do one or the other. Because here, the first one, 4n plus 5 times 4n minus 5. Difference of perfect squares. 4n, 4n, 5 and 5. 4n squared. 4n times 4n would be 16n squared. 5 times 5 is 25. So this should multiply together to give us 16n squared minus 25. But if we didn't notice that, and we went on and just did our multiplication, 4n times 4n is 16n squared, which we said was part of the answer. 4n times negative 5 is negative 20n. Even though we didn't list that as part of the answer, it will take care of itself. Our 5 times 4n is plus 20n. We see that those will simplify. And lastly, 5 times negative 5 is negative 25. When we combine like terms, negative 20n and 20n simplify, leaving us with 16n squared minus 25. So if we notice that they're difference of perfect squares, we can kind of skip a step to get us to 16n squared minus 25. If we don't see that, or we kind of miss that it is a difference of perfect squares, multiplying them out will get us to the same result. Questions on this here? 9y squared minus 2. Now, according to the properties that they were giving us for this here, a minus b squared would be a squared minus 2ab plus b squared. And we would plug in 9y as a, 2 as b, and kind of follow that pattern, which should give us 81y squared minus 436y plus 4. Now, it is possible to do it that way. I think it's a little bit easier for us to just say 9y minus 2 times 9y minus 2. Because whenever we have a square or cubed, it's just telling us we're multiplying that term by itself that many times. So here, if we multiply through, 9y times 9y is 81y squared. 9y times negative 2 is negative 18y. I think I was a little off on that. Negative 2 times 9 is negative 18y. And negative 2 times negative 2 is plus 4. And if we combine like terms, I can't remember what I wrote as the middle term previously, but we get 81y squared minus 36y plus 4. And that's it. Questions on this here? Unfortunately, we don't have enough time to go through doing the multiplication of ab plus 4 cubed. Yes. the squared, because since it said the quantity 9 minus 2 squared, the squared term says we have this. It's being multiplied by itself 2 times. The 3, or the cube per c, is saying that we have a plus b, or ab plus 4 being multiplied by itself 3 times. Does that make sense? Questions on this here? And that is it for this here. We didn't get a chance to get into the factor tree. If we do have time tomorrow, we can. If we do have time, that's fine. If not, that's fine also. It's nice, it's interesting, but it's not crucial.